My name is Gianluca Mardente. I work at Cisco in the AppDynamics business unit. And I also maintain on the side like an open source project, which is what I'm going to talk today about, which it's managing pretty much add-ons in a fleet of Kubernetes clusters. And what I'm going to do like today in this talk, I'm going to first go over a few slides where I explain pretty much what it is and how it works. And then I have a demo, live demo, that pretty much using some Civo clusters, of course. It's Civo, so seeing how it works there. So as you know, pretty much when you create a Kubernetes cluster, now you have to start deploying add-ons and applications, because at the end, the reason you create a cluster was to run your own applications. And if you're managing a fleet of Kubernetes clusters and you want pretty much to have consistency in the way you deploy add-ons on those clusters here, you need a tool that allows you to programmatically achieve that. And that's what pretty much Sveltos tried to solve. And the idea behind Sveltos is kind of simple. So you have this management cluster where Sveltos is running, along with the other tools you need in the management cluster. And every managed cluster is represented by an instance in the management cluster. So you can add labels on those clusters here. And then you can select, with using a Kubernetes label selector, you can select a set of clusters. And you can list the add-ons that you want to be deployed in those clusters. And Sveltos pretty much will take care of deploying those. So this is pretty much how the slides that shows like what happened. So Sveltos runs in the management cluster. Cluster profile is the main CRD that is used along with Sveltos. There are other CRD, but this is the main CRD. If you're using Cluster API to create clusters on demand, Cluster API, Sveltos has built-in support for Cluster API. So automatically, when you create a cluster with Cluster API, Sveltos automatically detect this cluster and, based on the labels, decide which add-on needs to be deployed. But if you have any other cluster, Civo cluster, GKE, any other type cluster that you have, you can simply register with Sveltos. The only things that you need to do is that you need to make sure that there is network connectivity from the management cluster to the managed cluster. And at that point, Sveltos pretty much will manage add-ons in those clusters as well. The cluster profile is the main CRD, and it has pretty much, as I was saying, it has a cluster selector, which is just a Kubernetes label selector. So in this case, it's selecting all the clusters which have the label environment set to FV, which stands for functional verifications. And then it has three sections. You can specify an Helm chart section where you can specify all the Helm charts that you want to be deployed. And you have a customization ref section where you can specify all the places where you have your customized file and directories. And what Sveltos will do, will take this information, will run the customized SDK, will take the output and deploy those resources in every cluster that is matching the cluster selector. And finally, you can also put your resources that you want to be deployed in config map or secret and have Sveltos reference those. Essentially, if you look at the config map, it has a data section. If you look at a secret, it has a data section. So within a config map or a secret, you can store one or multiple Kubernetes resources. When Sveltos, if you make cluster profile point to one of those config map, Sveltos will take the content of the config map and will deploy all the resources that are present there. For instance, in this case here, I do have a config map that contains in the data section a gateway class, a namespace, and a gateway instance. So if you create a cluster profile, so if you create this config map in the management cluster, and then you create a cluster profile which is pointing to this config map, anytime that there is a cluster that matches the cluster selector, Sveltos will take the content of this config map, so the gateway class, the namespace, and the gateway, and will deploy those three resources in the managed cluster that is matching the cluster selector. This is an animation to show pretty much how this works. So again, Sveltos is running in the management cluster, and there are two managed clusters. There is no label on those clusters yet. we create a cluster profile, and this cluster profile wants to deploy, we are telling Sveltos to deploy Caverno in every cluster which is matching the label environment production. Because those clusters have no label yet, Sveltos is doing nothing at this point. But as soon as I add the label environment production on the first workload cluster, Sveltos will detect that this cluster is a match for this cluster selector. It will take all the add-ons applications that are listed, in this case just the Caverno chart, and will deploy it. Same time, same way, if I add the same label on the second cluster, the flow will repeat. Sveltos will detect that this is a match. It will take all the add-ons that are listed here and will deploy those add-ons. What happens if I remove a label? The default behavior that Sveltos has is that it will detect that this cluster is not a match anymore. It knows what add-ons have been deployed because of this cluster profile and will remove all those applications. This is the default behavior, but it's configurable. You can tell Sveltos if a cluster stops being a match, you forget about that cluster, but you leave all the resources that deploy it. But the default behavior is that Sveltos will go and withdraw all the applications that have been deployed because of that cluster profile. Cluster profile is a cluster-wide resources. So if you create a cluster profile with a cluster selector, Sveltos will look for any cluster in any namespace, and if he finds a cluster that matches the cluster selector, it will deploy the add-ons. But sometimes it's also useful to say you don't want Sveltos to match any cluster, but you want Sveltos to match only cluster in a certain namespace. And so profile is the equivalent custom resource, which is namespace resources though. So if you use a profile and you create a profile namespace foo, Sveltos is only going to find cluster in the namespace foo which are a potential match for the profile. The reason you might want like the profile is because pretty much when you are a platform admin, so you manage like a bunch of fleet of clusters, but you're also onboarding tenants, right? So if you onboard tenants, pretty much like what you want to give, you want also give every tenant the ability to manage his own cluster. And so as a platform admin, you still create a cluster profile where you define the rules that needs to be, the add-ons that needs to be deployed in every cluster. For instance, the admission controller and the admission rules is something that typically you manage as a platform admin. But then you say like, okay, you have tenant one, I'll give you like namespace one, and you are tenant two, I'll give you a separate different namespace. So now as a tenant one, you can create whatever profile you want in your own namespace and whatever cluster you want in your own namespace. And the add-ons, your policy, the add-ons that you want to be deployed will be deployed only on your namespace. So tenant one will not interfere with tenant two, because if a tenant one puts like, says like, I want to deploy, I don't know, Nginx in every cluster which is marked as production, only the clusters which are present in the tenant one namespace will be matched and Nginx will be deployed like in DOS. So it will not interfere with the tenant two cluster. So this is the main difference. So depending on how you're acting, if you're acting as a platform admin, usually you go with a cluster profile. If you are a tenant which has been onboarded in the management cluster and has been given like a namespace, you use a profile. So you are limited to your own namespace. You cannot interfere with the other tenants. And the other tenants clearly cannot interfere with you as well. Sveltos has also 3 different modes in which it can work. So what I explained before with the animated slide, it was the continuous mode. Essentially in continuous mode, what happens is like you create a cluster profile. There is a cluster that matches this cluster profile. All the add-ons gets deployed. And now if you make a change in the cluster profile, let's say that you started asking that Caverno 300 needs to be deployed. That gets deployed. Now you go in the cluster profile and you say, now I want to upgrade Caverno to 310. Now Caverno gets automatically upgraded if you're running in this continuous mode. The one-time mode instead is when you are preparing the cluster for somebody else. Let's say that you need to create a cluster and then you need to give up the ownership of these clusters. But as part of the cluster creation, you want to put a set of applications that are present in the cluster before pretty much you transfer the ownership of the cluster. In this case, you can set the sync mode to be one time. In one-time mode, what Sveltos does, when a cluster is a match for a cluster profile, it deploys all the add-ons that are listed. But then if you make any change in the cluster profile or profile, those changes are not propagated to the cluster, because pretty much the role was one time. So deploy and then forget. And there is also a mode which is continuous with drift detection. You might, this is simply like a configuration drift detection. For instance, like I want to deploy, I decide that Caverno needs to be deployed in every cluster. Now I'll give somebody else ownership of the cluster, and they go directly there and issue like a kubectl delete of Caverno. Right now, the state of your cluster is different than the expected state, which is defined in the management cluster. So it's a configuration drift. So Sveltos in this mode here will detect that there is a configuration drift and will redeploy Caverno to make sure that the cluster is in the state that is defined like in the management cluster. But again, like it's every cluster profile has this mode here, so you can set like this mode in every cluster profile. The continuous, because essentially the sometimes you may say like I wanna continuous. I still want to decide from the management cluster what needs to be deployed in the cluster, but if for whatever reason, pretty much like you decide that you go directly to the managed cluster and you make a change there, I'm gonna respect that change unless I make another change in the management cluster. I'm not gonna override your change. But when you are configuration drift, with configuration drift, it will immediately reconcile back and override your change. It's just some people, I don't know, like the continuous because like pretty much they put the configuration and then unless it's an upgrade, they'll forget. And they're fine if you make like any change to the managed cluster. But if you instead want your cluster to be in the expected state that is defined like in the management cluster at any point of time, just go with the continuous with drift detection, and as soon as there is a configuration drift, Sveltos will reconcile back. So the difference with the continuous with drift detection essentially is that in the continuous mode, unless you make a change to the cluster profile, it's not going to reconcile back. So if you make a change, it's going to reconcile. But if you do not make a change, it's expected the cluster is good. But the continuous drift detection, it also keeps watching for any change in the managed cluster. And as soon as it detects a change, that it's drifting the configuration from the expected one, it will reconcile immediately.
Even if there is an upgrade to the local cluster, not the managed cluster, in the continuous drift, it will overwrite what is managed cluster has, right? In the continuous
drift, whatever you have in the management express, your intention that is expressed in the management cluster is going to always be true.
Exact replica. Whatever managed cluster has, the same replica will be have in the local cluster, right?
Yes.
But in continuous, I can have upgrades to the local cluster, but the managed cluster can have different version. For example, I have an upgraded version in my local cluster, but the managed cluster can have an older version. Is that true?
Sort of. So one example would be you start with a cluster profile and you say I want Caverno in every cluster which is production. Yeah. So now Caverno gets deployed, right? In continuous mode gets deployed. Now, while you are in continuous mode, you go to one of those clusters here and you delete Caverno. Because you issue like in the managed cluster directly, you went and did the kubectl delete of the Caverno deployment. So now Caverno gets deleted. Sveltos is going to say, because there is no change in the cluster profile, you issue delete directly in the managed cluster, you know what you're doing, I'm going to respect the choice. So unless now you come and say upgrade Caverno, I'm not going to do anything with it. So if you go to the management cluster and say upgrade Caverno, it's going to put it back with the newer version. But if you don't...
If I upgrade to version 2 in the local cluster,
it's still going to pretty much like respect that unless you issue a modification in the management cluster. But if you are with drift detection, as soon as you change the configuration in the managed cluster, So now it's different than the expected one. It will immediately override it back and say, look, this is what you wanted. You told me like to keep this way, and I'm going to keep this way. And yeah, pretty much like this is the example that with the configuration drift. The sync mode, it's set to configuration drift. As soon as we add the label environment functional verification, Sveltos detected this a match and will deploy Caverno. Now, as soon as Caverno is deployed, it also deploys pretty much an agent that starts watching for configuration drift. So if you, and Caverno gets deployed in the other cluster as well. Now, if you go directly to the managed cluster and delete the Caverno deployment, so Caverno gets deleted, but the agent is going to detect that this is a configuration drift. It's going to notify the management cluster, look, the configuration has changed, it's not what it's supposed to be anymore. And so from the management cluster, it's going to be reconciled back, and Caverno is back. Another cool thing about like Sveltos is that when you're managing a fleet of clusters, sometimes you want to express your configuration as a template, because you are deploying like the same application like in many clusters, and sometimes pretty much you have to put like slightly different configuration. And the problem is that like, you may not even know in advance what those values are supposed to be, right? In this example here, for instance, I'm deploying Calico and I want to pass Calico the pod cider block, right? But I do not know the pod cider, and let's say that I want to deploy this in every, this is like production cluster, right? I might have like 10 production clusters. I do not know like upfront what pod cider blocks is going to assign like to each one of those clusters, because maybe when the cluster is created, you know, I have a mechanism to allocate like a pool for that new cluster, right? So in this case here, you can pass Sveltos a configuration which is expressed like as a template. And Sveltos can fetch resources which are present in the management cluster at runtime, at the time pretty much. In this example here, when Sveltos is going to deploy, when Sveltos detects that there is a production cluster and it's about to deploy Calico, it takes the cluster instance that represents that cluster, which is a cluster API instance in this case. That cluster instance contains the cider blocks information. It's pretty much is in the spec cluster, sorry, my slide is very, can read it. It's in the spec cluster network pod cider blocks. It takes this information, instantiated and place and deploy. So essentially what you're telling Sveltos is, I have an application that I want to deploy and I'm giving you a template, and I want you, before you deploy it, fetch some resources which are present in the management cluster, fetch those resources, use data that is present in those resources, instantiate the template, and only then go and deploy. Because this is the case when you do not know like upfront the value. In this case here, like you do not know upfront what cider blocks is going to be, what is going to be assigned to every cluster. So if you want to create a configuration that applies to every production cluster, you have to express this as a template. And by default, Sveltos fetches like few resources which are present in the management cluster, essentially the cluster API cluster instance that represents the cluster in the management cluster, or the Sveltos cluster instance which represents like any cluster that has been registered to be managed by Sveltos. But you can instruct Sveltos to fetch any resource that is present in the management cluster. In this case here, what I'm asking Sveltos is, I want you to deploy the content of the config map, which is the namespace default called info. But before you deploy this config map here, I want you to fetch a secret which is present in the management cluster. If you see the template resource ref, that contains the resources that I want Sveltos to fetch from the management cluster. And in this case, I'm asking Sveltos to fetch a resource secret, which is in the default namespace, and call autoscaler. And I want you to identify these resources as autoscaler secret. So what Sveltos is doing is going to fetch this resource before deploying this content here. It's going to fetch this secret here, which is in the namespace default autoscaler, and identifies these resources autoscaler secret. The autoscaler secret identifier is important when we look at the content of the config map. And then it takes the content of the config map. After it fetches the resource, it takes the content of the config map. And now if you look at the content of the config map, the content of the config map is a template. You see, it's like, and is using the autoscaler secret. So now is creating another secret whose content contains the data token, which is taken from the secret that it fetched from the management cluster, and other information that is present at the secret there. Instantiate this template, and once this is instantiated, it takes this secret and it deploys to the managed cluster. So you can pretty much express any Helm charts value section as a template, or any resource that you put like in a config map secret as a template. And you can tell Sveltos fetch resources from the management cluster. This is the resource that you want to fetch. Instantiate the template and only then go and deploy. On top of the fetching resources from the management cluster, you can also ask Sveltos to deploy resource to the management cluster itself. Sometimes maybe, I don't know, an example, you may want to create a resource before you deploy something in the management cluster, before you deploy something else in the managed cluster. And so you can tell Sveltos to do that. If you see there is this deployment type, local means that Sveltos is going to take the content of this config map and deploy in the management cluster. While the content of this config map here, because the deployment type is remote, is going to manage to the management cluster. But you're guaranteed the order. Sveltos guarantees you the order. That what Sveltos is going to do is going to first fetch this secret, then it's going to instantiate and deploy this content here, because this is like going to go to the management cluster, and only then we'll move to this one and deploy to the managed cluster. So you have the order guaranteed. Yes, pretty much like this can be a template, right? And this can be another template. And you are instantiated both using information which is coming from here. But this is going to be deployed in the management cluster, and this is going to be deployed in the managed cluster. The use case will be, for instance, one use case might be that one thing that I've used, for instance, you want to deploy an application in a managed cluster. And this application here, you want to send some data back to the management cluster, do something in the management cluster. So one thing you can do, you can create a secret which contains a kubeconfig that you're going to pass to this managed. So you in this one here, for instance, you can create, a service account, right? So with some permission, for instance, like I create a namespace foo, and you can upload a config map in this namespace foo. So this one might contain like a service account and a role and a role binding. So now you deploy this one, then you take the kubeconfig which is associated to this service account, and you pass this information, you instantiate this other config map which is expressed as a template using this kubeconfig. This contains also pretty much a pod. Now the pod, for instance, when it comes up, it has a service account and a kubeconfig to access the management cluster and to do something in the management cluster. So I've used like this one for the autoscaler, because the autoscaler, when you run the autoscaler in the managed cluster, if you're using cluster API, the number of nodes is a resource in the management cluster. Right? So if you want to have like the autoscaler that automatically autoscale the number of nodes in the managed cluster, now you need to deploy the autoscaler in the managed cluster, but the autoscaler needs the permission to come back to the management cluster and increase or decrease the number of nodes, because those resources are cluster API resources, so they're there, right? So you need pretty much this workflow here, where you deploy something, but this must have like permission to come and do +1 or -1 on the number of nodes. So you need to create the resources like in, and because you're doing like for a bunch of clusters, you need like to go with a template. Otherwise, you're forced to create one profile for every cluster, which becomes like, error prone, because now when you have to change something, you have to change like 100 instances instead of one single place. Another case where I use the template. It's this one to, I don't know if you know, if you have used like the external secret operator. It's just it's a super nice open source tool that can sync if you have a secret management system, which is outside your cluster. Now the external secret operator can be configured to fetch the secrets from your external secret management and create a secret in your managed cluster, in your management cluster. And every time the secrets in your external secret management changes, it detects the change and sync it back. So if now consider the case where you have a secret that you want to distribute to every cluster that you manage. One option that you have is that you start deploying the external secret operator in every cluster that you manage. But it's kind of ugly, right? Because now every cluster has access to your external secret management system. Another way that you can do instead, you put like the external secret operator just in the management cluster. So the external secret operator syncs the secret from the external secret management system to your management cluster. Now, once the secret is in the management cluster, you can tell Sveltos, take the content of this secret here, because you can fetch any resources in the management cluster, and deploy in every managed cluster. So now you can deploy wherever you want. Now, if you do something like that, now if you change the secret here, because your secret has been leaked, you go to a single place, you change it here. Now this guy, the external secret operator, is gonna sync back in the management cluster, and Sveltos is gonna sync to all your managed clusters. So you make a single change here, and boom, it gets propagated like everywhere. It's like it's updated everywhere. One more thing that you can do, I'm always scared pretty much when I do something that is going to affect more than one cluster. I'm always scared about what the outcome is going to be. It's like, oh, I'm making this change. Like, if it's just my cluster, I'm fine. It's like, I'll deal with it. But yes, absolutely. Like, if I'm touching like other false cluster, I'm always scared. Like, I'm paranoid. Like, what is going to happen? Like, I'm going to break the cluster. Are they going to come to me? Like, so Sveltos has a dry run mode. So if you set Sveltos in dry run mode, you can make any configuration change to cluster profile and profile. Sveltos will run the entire logic, but no configuration gets changed in the managed cluster. But then you can go and use like this Sveltos cuddle, which is a CLI that comes with Sveltos and says like, because of my change, what will happen? And in this case here, what Sveltos is going to say is like, oh, your Caverno will be upgraded from 2.5.0 to 2.6.0. And by the way, you also have like a Caverno cluster policy deployed, and this will be updated. So I can preview this change, and if I'm fine with what the outcome is, like if I actually expected that Caverno will be upgraded like in those clusters here, and that this latest policy will be updated, I can go and set the mode from dry run back to continuous, and it will deploy it. If this is not what I wanted, because it's in the runner mode, nothing has happened. Like, so I can go back and pretty much revert the change back, and there is no cluster which is affected by this change. And again, maybe it's just me, but when I'm touching like other false cluster, like I'm paranoid. It's like I'm gonna touch like unless I know what is going to happen. Yeah, I've been burned like a few times when then like nothing happens. You go back home and then middle of the night you get a call. It's like, oh, everything is red. It's like, what did you do? It's like, why?
It's not their cluster, it's one cluster. The clusters are down.
Yeah. Yeah. And, and people never realize till it's midnight, right? At midnight is when they realize, and it's when they call you. Or your weekend. Now, with respect to scalability, right? Sveltos has a built-in, you can manage, I would say that if you go up to 50 clusters, the default configuration is fine. You don't have to do like anything else. But if you go above that number, Sveltos has a built-in way to scale up. So for instance, like let's say that this is like I've reached like 50 clusters, and now I'm going to add another cluster. The only things I need to do is just when I create this new cluster, I can add like a new, I can add an annotation to this cluster here. As soon as Sveltos sees that there is a cluster with this annotation, it understands that, oh, you want me to scale up. So it creates another instance, which is going to take care of those new clusters with using new label. So the first Sveltos instance is going to take care of all the clusters that we already have. And the new Sveltos instance is going to take care of the clusters which have this annotation shard production. And so if you keep creating clusters with this annotation, like, second Sveltos instance will take care of it. If you want to scale up again, create like another cluster with a new annotation, and boom, Sveltos automatically detects like, oh, okay, you want me to scale up again, so I'll scale up again. And it creates a new instance. Same way scale up is scale down. If you remove all the clusters with the annotation shard pre-release, Sveltos will remove one of the instances automatically. So you don't have to do anything. Just add the annotations on the label, and Sveltos will take care of scaling up and scaling down. And all these Sveltos resources are running in the management cluster. So as long as your management cluster has enough nodes for those pods to run, then you're good. Yeah, this is the presentation. Now I'll go like on the demo. If a few pointers here, there is the GitHub page with the documentation. If you have like any feedback or any idea, pretty much the Slack channel is the best way to ask questions, like, or suggest feedback, provide feedback, or if you see something that doesn't work, report bugs. And happy to connect on LinkedIn as well. Like if you find this interesting and you want to discuss, it's Gianluca Mardente, I'm on LinkedIn, so happy to connect. So this is everything for the slide. So now we'll go to the demo. So and I'll make this. Let me know when it's readable. Hopefully this is readable. Right? Okay. So I do have, right now all the kubectl commands that I'm issuing are going to the management cluster. And so, well, unfortunately, pretty much like, okay. So there are, let's look at the namespace, it's easier. So there is a Project Sveltos namespace where the Project Sveltos controllers are running. And I'm also using cluster API. And I do have one cluster API cluster, which I did create, which is using Docker as infrastructure provider. So this management cluster is running as a kind cluster on my Mac. And I also have another kind cluster, which has been created through cluster API using Docker as infrastructure provider. But I also have some Civo clusters. So I created like 3 Civo clusters, and I registered those clusters to be managed by Sveltos. And now I'm going to create pretty much yet another cluster on Civo, just to show like how easy it is like to, first of all, how easy it is like to create a cluster on Civo. It's really like amazing. I love it because it's very cheap to create a cluster, and it's very fast to create a cluster. So I'm creating a cluster, and I'm going to call it cluster 4. I'm create like the medium-sized cluster because for this demo it's good enough. And I'm going to pick like 128.2 as a version. So then I hit create. This takes like roughly like 90 seconds to fully provision the cluster for you. So right now it's 120 seconds. But while this happens behind the scene, we can wait for that to happen. But pretty much those clusters have already registered. I want to show like something else. So there is this Sveltos Cuddle. It's a CLI that comes with Sveltos. It's no need to use, but it's very handy. I use it because pretty much like I put the commands that I use the most, like to show what add-ons are deployed where, to show what will happen if I go like in dry run mode, what changes will happen. So it's very easy to read the changes. And so far, pretty much there is no add-ons that has been deployed yet. The only things is that I want to show is that all those clusters here have this special label, environment functional verification. So any configuration they're going to push, I'm always going to use like a cluster selector, which selects those clusters here with this label, environment functional verification. So let's go back to Civo. It's 60 seconds left.
Sorry, while it's starting up, the template.
Oh, 5 minutes. Oh, okay. Sorry.
Template thing we saw earlier, that's standard Go template, so we can use any range and X functions there are.
You can use like any Spring function that it's yes. You can use all those. Yes, it's support pretty much in understands like it understands all those. So because there are just 5 minutes left, like let me just try like I'll deploy this. Just go here and I want to deploy like so. I have like this cluster profile. So the Civo. I have this cluster profile here, which will deploy in every cluster which labels environment verification, which are functional verification, will deploy Caverno. So I'll start deploying this one. Kubegado apply this. And I have another one which it's with drift detection. So what I'm saying is like deploy Nginx in every cluster with this label here. So I'll deploy this one as well. And now if I just start like watching for the one up, and on controller, if I start watch for those, you know, it has already deployed, try to make like this, it has already deployed, you know, it's like you can see it starts deploying things. Like, of course, like local is going to be much faster because it doesn't have to go like over the network, but then the Civo cluster is already like start deploying things in the Civo clusters as well. It's going like over the network and it's deploying all those things here. This is deployed everything. I think at this point, this has created the cluster. Now, just to show how easy it is like to register a cluster, the only things I have to do, I create a cluster with Civo. I download the kubeconfig. So I downloaded the kubeconfig, and there is this command register cluster where I say like, okay, I want to create like a cluster for. I know that because of this cluster name and know where the kubeconfig is in my download Civo cluster for kubeconfig. I'll issue this command, and if I go and watch the get Sveltos clusters, you see it's like it has already registered this cluster here. It's it detected this was the version, so it's there. So now if I just add the label to this cluster, edit Sveltos cluster in Civo, and it's called cluster 4. So if I add the label here, environment functional verification, Sveltos will detect that this cluster here, it's environment FE. It will detect that now this is a match, and if I go back and watch the add-ons, now I should see that it starts deploying pretty much those add-ons like in the Civo cluster 4 as well. I'm sorry, like I thought like I had more time. I want like to do like to show more things, but my bad. One thing that I want to show, because we are here, like I think I have still 1 minute, right? So this I think I can show. So if I go here, right now like I'm going to one of the managed cluster, right? And we deployed Nginx. And we deployed Nginx with asking Sveltos to do like continuous with drift detection. So I'm going to issue a delete of the Nginx deployment directly to the managed cluster. So I deleted it. Now, if I start watching for it, Sveltos should detect that the Nginx cluster, the Nginx deployment has been deleted, and it should reconcile back. So network connectivity. Okay, so yeah, it came back. So it deployed back. So yeah.
Yeah, very nice. Yeah.
Thank you. Thanks. And yeah, it deployed also pretty much in the cluster 4. It deployed like the other uncharts there. So everything it's worked as expected, luckily. Thank you so much. Thanks.